Today we are going to talk about the chain rule. This is a very useful, often used rule for finding the derivative of a function. Let me introduce this to you. Let's consider this function. Y is equal to 7x squared. If we want to find dy dx, we can very simply use the product rule. 2 times the 7 is 14. Write the x, reduce the power by 1, and we're done. Very nice. What if we were given y is equal to 7 times 3x plus 1 squared? Rather than just a plain x squared like we had here, what if we have a 3x plus 1 in there? How would we find dy dx there? Well, we could multiply this out. So I could take this and say that 3x plus 1 squared is the same as 3x plus 1 times 3x plus 1, which is, when I FOIL this out, 9x squared plus 3x, so plus 6x plus 1. And then I can distribute the 7 through, and I get 63x squared plus 42x plus 7. And now that it's in polynomial form, I can just apply the power rule to find the derivative. 2 times 63, reduce our power by 1, plus the derivative of 42x is 42. The derivative of 7 is 0. So this would be the derivative of that function. What if we had 7 times 3x plus 1, instead of being squared, what if we had it raised to the 9th power? Well, I guess we could multiply this out, multiplying 3x plus 1 by itself 9 times. We would be foiling for about a half an hour. Hopefully we would not make any multiplying or addition mistakes, but it would take a little time. And then we would apply the power rule to that 9th degree polynomial. It would be a tedious and time-consuming process. Fortunately, we don't have to do that. We can apply what is called the chain rule. So this is the chain rule. The chain rule says this: when you're trying to find the derivative of a composition, which is exactly what this is. It's exactly what this was too. But this is a composition. It doesn't look like it, but it is. Instead of just a plain x in here, this is another function. We could call that g of x. So this is like the 7x to the 9th, but instead of a plain x, we have g of x. So it's a composition. So what we will do is, we will take the derivative of the function, acting like this is a plain x, take the derivative of the function. And then we will multiply by the derivative of the inside. Okay? Another way to think about that is, instead of thinking of this as a g of x, call it u, or some other letter. Nothing magical about the u. We can take the derivative of 7u to the 9th. That would be the derivative of y with respect to u. And then we would multiply by the derivative of u with respect to x. So at the very end, either way you think of it, at the very end, you're multiplying by the derivative of the inside of the parentheses. Okay? Take the derivative as you normally would if it was not a complicated inner part, and then multiply by the derivative of the insides. Let's take a look at some examples. Let's say that we have f is equal to this function, and we want to find f prime. All right, so I think of this as, this is my inside here. I'm going to treat that like I would a plane x. F prime of x would be, I'm just going to use the power rule like I normally would. I'm going to, this exponent, multiply it by any lead coefficient, reduce our power by 1. Okay? Now, very important, leave your insides. In this first step, leave your inside. So whatever this is, you're going to write it right here. Don't change your insides. Okay? Now, our last step is to multiply by the derivative of the inside. So I multiply, make sure you multiply, don't add. Every once in a while I'll see students add here. Don't add, you multiply. Multiply by the derivative of your inside. 4x cubed minus 6x plus 9. So this is, again, the derivative of the inside of your, and I use quotes around that. That is not a mathematically rigorous description of that, but it is the derivative of the inside of the parentheses. Okay? And again, let me reiterate, leave the inside alone. Again, I'm using that term inside. That was inside of your original parentheses. Leave the inside, reduce your power by 1. Lastly, multiply by the derivative of your inside. Number 2, find the instantaneous rate of change. That's just another way to say derivative of this function. So y is equal to 9 parentheses 2x to the 7th plus 5, all raised to the 4th power. Okay? So, instantaneous rate of change, that's just your derivative, your instant slope. Power rule. 4 times the 9 is 36. Leave your inside alone, decrease your power by 1, and lastly, multiply by the derivative of the inside. 14x to the 6th plus 0. As a multiple choice answer, they would multiply the 36 times the 14 and put the x to the 6th out in front. So whatever that is, I'm not going to multiply that out, but they would multiply that out, move your x to the 6th out front, and then write this part last. So that would be the multiple choice answer. Number 3, what is the slope of the tangent line? That's another way to say what is the derivative to this curve in terms of x. Okay, so here's our g of x. Copy this down. All right, g prime of x is equal to power times any coefficient. It's going to be 99. Keep your inside, decrease your power by 1, multiply by the derivative of the inside. 3x squared minus 1, and you're done. Okay? All right, let's see how we can do this with trig functions. So we have h is equal to sine of 4x, all right? Not a plain x in here. So the first thing I'm going to do in finding this derivative is just take the derivative of sine as I normally would. The normal derivative of sine is cosine. So cosine of, very important, just like we did here, keep your inside. Keep your inside there. Then you multiply by the derivative of your inside. The derivative of 4x is just 4. So as a multiple choice answer, they would put that 4 out in front, and this would be the multiple choice answer. So the derivative of sine of 4x is 4 cosine of 4x. Again, Your argument is not going to change. Don't change your argument, okay? Let's do another one. Okay, what is the slope of a line tangent, another way to say derivative, to this curve at the point when x is pi over 12? Okay, I'm going to write down what g of x is. Okay, g prime is equal to, all right, the 3 is just going to be multiplied by our answer. It's not going to, we don't have to do anything else with it. Just keep it and multiply by it. Now I'm looking at the cosine. The derivative of cosine is negative sine, right? So this is going to be a negative 3 sine of, keep your 2x. Don't change your inside of your parentheses. And then you're going to multiply by the derivative of 2x, which is just 2. So this would be, as a multiple choice answer, negative 6 sine of 2x. Okay? What if we have this one? Well, anytime I have a cosine or a trig function raised to a power that's not 1, any power that's not 1, I rewrite it. First thing I do is I rewrite it, at least in my mind, even if I don't write it on paper. In my mind, that's what I'm thinking. Okay? So now we want f prime of x. Well, chain rule. I have something being raised to a power, so chain rule it. 6 times the coefficient, leave your inside alone, reduce your power by 1, and now you multiply by the derivative of your inside, negative sine x. As a multiple choice answer, they would pull that negative to the front, make it 6 cosine to the 5th x sine x. That would be your multiple choice answer. Okay, number 7. Y is 8 tangent x. We're asked to find the second derivative of y with respect to x. So first we're going to find the first derivative, and that we did a few sections ago. The derivative of 8 tangent x is 8 secant squared x. And that's fine and good, but now we need to take the derivative again, so I'm going to rewrite this as 8 parentheses secant x squared. That's going to allow me to take the derivative of using the chain rule. So now we're going to take the derivative again. So we are taking the derivative of both sides with respect to x. That gives us the second derivative of y with respect to x. That's the traditional notation for a second derivative using this dy dx form. So 2 times the 8 is 16. Keep your secant x, decrease your power by 1, and now multiply by the derivative of the inside. Secant x tangent x is the derivative of secant x. So this gives us 6. We have 2 secant x's and a tangent x, all multiplied together. No pluses in there. Okay, alrighty. Number 8. Find the slope of the line tangent, that's just another way to say derivative, to this function in terms of x. Well, the first thing I'm going to do is I see this 4 as a power, so I'm going to rewrite this as sine of 3x squared all to the 4th power. Okay, when I see that all to the fourth, I think it's a big chain rule. So dy dx is equal to 4 times the lead coefficient, just a 1 there, so 4 times 1 is 4. Keep your sine x, or sine of 3x squared, keep it, reduce your power by 1. Now we need the derivative of the inside. What's the derivative of the inside? Well, the derivative of sine is cosine. Keep your 3x squared, right? The derivative of sine is cosine. Keep your argument. That never changes. And then at the end, multiply by the derivative of your argument, 6x. As a multiple choice answer, they would multiply the 4 and the 6 together and move the x to the front. So 24x. We have 3 sines, so sine cubed of 3x squared, and then cosine of 3x squared. I want you guys to notice something. This would be the multiple choice answer. I want you to notice something. The argument that we started is always your argument. In every piece, it's your argument. Never change your argument in a trig function when you're finding the derivative. Okay? Let's do another one. Here we have p of x is secant to the 7th of this, and we're asked to find the derivative. So I'm going to rewrite p first, because I see this power on the trig function. So I need to rewrite that as secant of 9x squared plus 2 all to the 7th power. Now I'm going to take the derivative. 7 times the lead coefficient. Keep your secant, and of course keep your argument. Decrease the power by 1. Now we're going to multiply by the derivative of the inside. The derivative of secant is secant tangent. Keep your argument. So I'm going to write this, secant tangent. Always keep your argument. And now lastly, I need to multiply by the derivative of our argument, that 9x squared plus 2. So I'm multiplying by 18x. Okay, as a multiple choice answer, again, they would multiply 7 times 18. I guess I can do that. That's 56 plus 5 is 126. Bring your x to the front. Okay, how many secants are there here? There's 6 here and 1 here, same argument. So that's going to be secant to the 7th, 9x squared plus 2 times tangent, 9x squared plus 2. Always the same argument. This would be the multiple choice answer. Okay, so those get nice and long, nice and involved and fun. A couple more examples here. Let's find the instantaneous rate of change. That's another way to say derivative of this function. Okay, well, I do need to rewrite this. This is a square root, so I need to rewrite that as 2x to the 4th plus 3x minus 1 all to the 1/2 power, because a square root is a power of 1/2. When you write it like this, it should become very clear that you're using the chain rule. So f prime of x is equal to 1/2 times the lead coefficient. Keep your middle, keep your inside. Decrease your power by 1. 1/2 minus 1 is negative 1/2. And then multiply by the derivative of the inside. 8x plus 3. Okay, that's all fine if it was an FRQ, a free response question, as a multiple choice answer. This negative power, they would send it to the bottom. Now this 2 is already in the bottom, so this would be sent to the bottom with the 2. The 8x plus 3 would remain on top. So on the bottom we would have that 2 from here, and then this would be to the positive 1/2 power, which I'm going to send back to a square root. I often see AP in their multiple choices send a power of 1/2 back to a square root. So this would be the multiple choice answer. Okay, one last example. Find h prime of 3 if h is this. Now, when I see this, I think I could do this a couple of different ways. It's a quotient, so I could use the quotient rule. Or I could bring this to the top, give it a negative exponent, and then use the product rule. Either way is fine. It's written as a quotient, so I think I'm just going to use the quotient rule. Okay, so I'm going to find h prime of x, and then I'm going to plug in 3 for x. Okay, quotient rule. We start on top, take the derivative. The derivative of x is just a 1. And then I multiply by the bottom left alone. Okay? Minus is part of the quotient rule. Now I'm going to leave the top alone and multiply by the derivative of the bottom. The derivative of the bottom involves a chain rule, because the square root of 2x minus 2 is 2x minus 2 to the 1/2 power. So I'm taking the derivative of this thing, and that's a chain rule. So 1/2 times the front will be 1/2 times the 2x minus 2 to the, decrease your power by 1, negative 1/2, times the derivative of the inside, 2. So chain rule on that. Now, back to the quotient rule. This is all divided by the bottom squared. Well, the square of the square root is just what's inside. So we just have 2x minus 2 for that part. Okay? All right. I think I will clean up. I was going to say I could go ahead and plug in the 3 or clean up first. And I think I'm going to clean up first. So 1 times the square root is just the square root. Minus. All right. This 2 here will cancel with this 2 here. That's nice. So that 2 is now gone. This x is just x, but this has a negative exponent. So I'm going to write this as a square root and put it on the bottom of this x right here. So I'm going to have x over a square root of 2x minus 2. That takes care of that part of the numerator, but I'm still dividing by 2x minus 2. Alright, now I'm going to plug in 3 for x. And when I plug in 3 for x, 2 times 3 is 6, 6 minus 2 is 4, and the square root of 4 is 2. So that is just 2. Minus 3 divided by that same thing that we just found, that was 2. All divided by 6 minus 2, which is 4. I'm going to multiply top and bottom by 2 to get rid of this little denominator here. And I have 4 minus 3 all over 8, which is 1/8. Chain rule can get very involved. Keep everything straight and you'll be fine.